Hi guys. If you remember from yesterday, we went over the first part of this lesson. We talked about the properties of parallelograms, and today we're going to finish the lesson talking about properties of rhombi and trapezoids. Now, a rhombus is a parallelogram, meaning that it is a quadrilateral with opposite sides parallel. But not only is a rhombus that, it's a special parallelogram in that all the sides of a rhombus are equal in length. Okay, and that's what these hash marks mean. Since there's one hash mark in each side, every side that has the same amount of hash marks means they're all equal in length. So no matter what the length of this one is, one hash mark means that it's equal to this and this and this because they all have the same amount of hash marks. See, all of these sides are equal in length because they all have one hash mark. If they weren't equal, for example down here, if these two sides had one hash mark but these two sides had two hash marks, well then the ones with one hash mark would be equal in length and the sides with two hash marks would be equal in length. But I just made that up. That's not the case. I just wanted to show you about the hash marks. Okay? And so all of these sides here are equal in length as well as here. And here you can see the definition of a rhombus. It's a four-sided figure, which means it's a quadrilateral, in which the opposite sides are parallel, which then makes it a parallelogram, but all four sides are equal in length. What else do you know of that has all four sides equal in length is a square. So a square is a rhombus, but it's a special kind of rhombus, which we will not get to right this second. Which figures are, this says rhombuses, I say rhombi. That's another way in English to say the plural form of something that ends in an S, so you don't have to say so many like I'm from Arizona, instead of cactuses, we say cacti. Okay, so this may say rhombuses, but I'm going to say rhombi. Anyway, this says use a ruler and a drawing triangle to find out which ones are rhombi and which ones are not. We're not in person, so I am not there to help you with a ruler and drawing triangle, so we're going to try to eyeball it, because these pretty much you can eyeball. Would you say that, oops, I need my pen here. Would you say that this one is a rhombus? Do all sides look equal in length? No. Would you say that this is a rhombus? Are all sides equal in length? No. Those are easy to see with your eyes. Now these middle two, you would really need to measure with a ruler to know for sure, but I'm going to tell you right now I already measured them. And this one, all sides are equal in length, therefore it's a rhombus. And this one, all sides are equal in length, so that's a rhombus. Now to find the unknown angle measures of a rhombus, it's the same as a parallelogram. Remember this one from parallelograms? Opposite sides are equal. Okay, so if this is 65, this is also 65. And we're going to do the same thing that we learned yesterday. These two have to equal 180, just as these two do. So 65 plus, I'll just say, angle C equals 180. What does that make C to be? Well, if we subtract 65 from both sides, that means C is 115 degrees. So this is 115 degrees, and if that is, so is the opposite angle. Same thing here. I'm going to go a little bit faster on these. Okay, if G is 83 degrees, then E is 83 degrees. Let's see, 83 plus F equals 180. I'm going to do that math in my head just to keep this video a little bit shorter instead of doing algebra. That means 97 degrees. So that's 97 degrees, and the opposite also has to be 97 degrees. Okay, same thing here. If this is 124, then the opposite angle is 124. Now this wants to know what KML is. That's this one. We can do that though, because if we subtract 124 from 180, we will get 56. So this whole thing is 56 degrees. That means this whole thing is 56. If we do 56 minus 28, we'll get this one right here. I'll use the red one, that one right there. So let's see, 28. Oh, I guess I knew that. 28 degrees. Next slide. A little bit more practice with the exact same thing. This wants us to figure out angle DAB, which is this. So this is interesting because we have to use things that we've learned before. If this is a rhombus, that means that this side is equal to this side, which means that, let's switch this to green or something, which means that this is an isosceles triangle, which also means that if this is 64 degrees, so is this. So, and if this is, well, let's just talk about this, then this is also an isosceles triangle. If this is 64 degrees, so is this. So that means each corner is 128 degrees fully, and I guess that's all we need because DAB is right here. So that's 128 degrees, and we could go further and figure out the other two, but from the question it's asking, we don't need to. And now the purple one, angle ADE is what we need. ADE, so that's this one. If this one's 105, then this is 105. And that means that this whole thing, they have to equal 180 degrees. So 105, we could do 105 plus 50 plus D equals 180, which is, let's see, 165 plus D equals 180, and I can do the rest of that in my head. That's 15 degrees. So 15 degrees. And this is 128 degrees. Now trapezoids are a little bit different. Trapezoids are not parallelograms. They are quadrilaterals that only have one pair of parallel sides. As you can see in this bluish colored one, this side is parallel to this side. The other two are not parallel. And here are some more examples in pink. This side is parallel to this side's parallel to this, and this side is parallel to this. As you can see here by the definition, a trapezoid is a four-sided figure which only has one pair of opposite sides parallel. Now that makes a difference in how we figure out some angle measurements, which we will see on the next page. But here, which is a trapezoid? In this one, do you see any sides that are parallel? No, so this is simply a quadrilateral. Here I see in the yellow one, these two sides look parallel. So this is a trapezoid. And in this one, do you see any sides parallel? I do not. So there's only one trapezoid in this, the yellow one. Now in trapezoids, there are not any opposite angles equal. It might happen accidentally, but not accidentally, but with some of them I should say, but it's not a rule for trapezoids overall at all. But what do you notice here? What do you notice here with the blue and the green? Do you see that they create a straight line, a straight angle, which equals 180? And do you also see that with the pink and the, I don't know what color that is, yellowish, brownish, orangish color? They also make a straight angle, which equals 180 degrees. So what can you say? How can you describe which angles equal 180 degrees? What do you think about describing it like this? The two angles that are next to each other, in math we call that adjacent. Here, I'll show you how it's spelled. Adjacent. So the adjacent angles that are neighbors, not all adjacent angles, but the two adjacent angles between the parallel lines. Do you see, let me change this to red. So would you say segment AB and segment DC are parallel, right? So the two angles next to each other between them equal 180, and the other side too. The two angles adjacent to each other, they're neighbors, right between them are 180. So that's the one way that you can figure out some missing angles. Let's practice that on the next page. So segment A, B, and CD are parallel to each other, and so these are going to equal 180. So 85 degrees plus what equals 180? 95. Now again, there are no opposite angles are equal, so we just have to do that again right here. 130 plus what equals 180? 50. See, none of these are the same, but there is still a pretty easy way to figure that out. Let's practice some more. Remember from the last video I told you about when it says not drawn to scale. It means you can't use a protractor on these. It will not help you. Now in this number 15, the purple one, it does tell us that segment AB is parallel to segment CD, or DC, whatever you want to call it. It's asking us to find the unknown angle measure. That's why this little mark is here. Okay, let me change it to a different color. This little mark right here, the green mark. There is not a mark here or here, because as I'll show you in a minute, there's not enough information to even find those. So we know that the adjacent angles between the two parallel lines equal 180 degrees. So 106 plus angle C, if we subtract 106 from both sides, I can do that in my head pretty fast, that is 74 degrees. Now in order to find these two, we'd have to know one of them, but we don't know either one of them. So we can't find those out at all. It's not possible with a trapezoid. Okay. Now let's look at number 16. Segment LM and KN are parallel, which you can't take for granted. You always have to look at the directions and make sure it says it right there. So that means that these two equal 180 and these two equal 180. And it does want us to find all those, because that's why there's a little mark right there for the unknown angle, and that one too. And so 118 plus what equals 180? Let's see, 62. So this one's 62. And then 153 plus something is 180, 30, that's 27. See how we do that? We definitely have to identify the correct angles between the parallel lines in order to know what two angles equal 180 degrees. And these are the last two we're going to practice together. Again, it says that these trapezoids are not drawn to scale, so don't use a protractor. That's not going to work out for us. Looks like we need to find this one. So we know that those two angles equal 180. So we know 46 plus the question mark plus 32 equal 180. Let's see, that's 78. I can do the rest of that in my head. How about 102? That's 102. And we don't have enough information to do those. Let's move on to 18. We need to figure out this one. Let's see, the parallel lines would be AD and CB, and we know that between those, these are going to equal 180. So we can do the 112 plus the missing one plus the 24 equals 180. Let's see, 112 plus 24, 24, 34, 36, 136 plus what is 180? I'm coming up with 44. 44 degrees. There we go. And you guys are going to do these in the Ed puzzle, as well as the ones on the next page. So there are 6 different ones to do in the Ed puzzle. Go ahead. Good luck.